Hello everyone, this is a video on the Curvy Copter 3 puzzle, which is a jumbling puzzle. This means that I can move the edges, in this case of the puzzle, by 180 degrees, but I can also move the edges, two edges, by less than 180 degrees, and I perform what is called the jumbling move. This will be a very short tutorial in which I will show just the method and the main algorithm you need to solve it. For the notation, I will call this edge front, right, back, left, this down. For the other one, I will add an additional information like, for example, right up or right front. And this is the cube scrambled. This cube is a superset of the classic Curvy Copter cube, meaning that it has additional pieces. The way we solve it is to solve the Curvy Copter cube bits, and this will leave some pieces left to be solved. I will not spend too much time on the first part of the solve, where I solved the Curvy Copter, the standard Curvy Copter part of the solve. The first step is to give to the puzzle a cubic shape. In some cases, the puzzle can be completely messy, and in this case, just to show what it means, I have only a situation where just a bit of the puzzle is not in the cubic shape. I won't waste time on this, because if you are solving this cube, you already know probably the Curvy Copter cube, and this is quite an intuitive solve. So you just have to play around a little bit till you give it the correct cubic shape to the puzzle. The next step is to fix one face. I usually start from the white. You can tell which face you are on just looking at the edges, because the edges can turn but cannot be moved to a different position. So for example, by turning like this, I see that this is the white faces. I can tell this is the green faces because I go and so on. I need to put the four white outer pieces on the white face with the correct orientation of the edges. So, for example, I can do this. This is correct. I need to turn this off. Okay. This is quite intuitive, and usually is very simple. Okay, this is correct, but I need to turn this, which can be done just doing that. So I have four outer pieces and the four edges correctly oriented. What I do after that is to place the corner on the white faces correctly oriented. For example, this corner goes here because it's a blue and yellow, but I need to turn it. To turn it, it's enough to make it go around the up face like this, all around. So I need to go around one more time. Okay, this correctly placed, this is correct, and so on. This is blue, this is, I go around. And the last one is here. Once again, I go around on the other direction. And here we go, we have all the four corners fixed. Okay, now that I have all these pieces in place, I need to be sure that the corner are correctly oriented. This is correctly oriented, this is correctly oriented, orange and blue, blue and red, this is not. To orient the corner is very simple. I turn it. I take this corner which was here out of the way. I turn it again. I put back this corner. I put it back. So now I have the corner in place as before, and this one correctly oriented. Then I need to place these outer centers. I can do this with this algorithm. For example, if I want to put this orange in here, which are on two faces next to the other, I just use the algorithm front right, right, front, right, front, right, and the pieces goes in place. And this for pieces that have to go from here to here, I can use the symmetric algorithm. Maybe in a situation where, for example, I can find a right place to put in here. I want to put a red place in here. And this is because the red piece is not in the correct orbit. You see there are two red here, but I really should have a red here to be able to put it. This is an orbit. To be able to put it in here. So what I want to do is to use the jumbling move to switch these two pieces in their orbit. This piece will go in the orbit of this one and the other way around. To do that, I just move the two lateral edges, so the two pieces to swatch are on the side, and I perform the jumbling move. I undo the setup move, and now, as you see, the red piece is in the correct position, and it can be placed with the move we have seen before, which is front right, right front, right front right. You see the piece is in place, this corner is still in place, the edge is correct. When all the down part of the cube is done, I need just to place this outer center here, which is quite easy and intuitive. Can be done just moving around. This is done, this is done. This is done, and this is done. It's very easy. If you don't manage to finish this part, which is very easy, it means that two yellow pieces are switched, okay? And this will prevent you from having all the pieces in place. In this case, once again, you switch the two using the jumbling move. I mean, if I want to switch these two, I put them on the side and I perform the jumbling move, as I've seen before. This is a general rule from the beginning. Even when you do the white, if you can complete it, it means some piece is not in the correct orbit. So you need to put it in the correct orbit by using the jumbling move. By switching that piece with a piece in the orbit where you want to go. Now that all the outer center are fixed, the next thing to do is to orient the edges. This is oriented, we need to orient this one. To do that, we need to perform two jumbling moves in a row. We start what I call the right jumbling move. So, starting from the right. Then we perform a left jumbly move. Okay. The net effect is that two pieces will be switched twice and we go to the original condition. So we then perform an F move to put these pieces back in place and the edge will be oriented. Remember, the last bit where you fix all the outer center is easier than you think. The trick is to be sure that each piece is in the correct orbit. You can easily see in which piece each orbit is, in which piece it can go. You know how to swap them with a jumbly move. And when every piece seems to be in the correct orbit and still you can complete it, then as I said before, you need to switch to yellow. Now on the corner of the edges are correctly oriented, we need to put the corner in place. This is in place. We perform a 3 cycle that will keep this corner in its position and will cycle this one, this to this, this to this, and this to this. The algorithm is right, left, back, left, back, right, back, left, back, left. This is now in place, this is in place, this is in place, this is in place, this is in place. Okay, the last thing to do is to orient the vertices. This is oriented. We will use an algorithm that will rotate these three and will leave this unchanged. It is quite a boring algorithm. You need to perform front, right, back, left moves 6 times in a row. So it's 1, 2, 3. After the first 3, I go back to the original position with all the edges flipped. 4, 5, and finally 6. As you see, now all the Ruby Copter, the standard Ruby Copter bit of the cube is solved, and only the additional pieces present on the Ruby Copter 3 needs still to be solved, which are the centers and the outer triangular centers. Once the subset of the pieces equivalent to the Curvy Copter, to the standard classic Curvy Copter, are solved, now we need to solve the center first and then the outer triangular centers. For the centers, we have a 3 cycle in which we move one center, this center to here, this center to here, and this goes to here. It's very simple. So the white center is already in place. We want to put the red here. So the algorithm is simple. It's right, left, right, left. As you see, the red that was here has gone here, and we have the green here. Now, for example, we want the yellow here. So once again, the yellow will go here, the orange will go here, and the green, okay, will go here. So we have right, left, right, left. Okay, once we have 3 in a row, we need to sort out these 3, which is simple. We want the orange to go here. So we can perform this way, or we can perform this way with the symmetry, which is in this case left, right, left, right. All the centers are fixed, and the only piece that need to be fixed now are the outer triangular centers. To solve the last outer center pieces left, we basically use one algorithm and its symmetry, which is a 3-cycle between this piece, and this piece. The algorithm is very simple. It's right, left, back, front, back, and on the other side, left, right, back, front, back. As you see, the red piece which was here is now here, and this is a 3-cycle. If we want to do the cycle in the opposite way, we can reverse the algorithm, which is not difficult, or simply because these two pieces are in the 3-cycle, if we do this setup move, we perform the algorithm, and then at the end of that we undo the setup move. The net effect is to have a 3-cycle in the opposite direction. With our basic 3-cycle and some setups moves, we can perform any 3-cycle among pieces on the cube. The way it works, we perform the setup move, we perform the 3-cycle, and then we undo the setup move. This is what makes this puzzle interesting, because sometimes you have to solve complex situations, you have to think the correct setup move, and then after the algorithm you need to remember the setup move and undo it. However, if you get stuck, I'll give you 4 basic setups move you can learn and remember, that I use to swap element between two faces next one to each other. And one of the setup move I'll give you is even a 3-cycle between element of the same face. Of course, once you can swap element between two faces, you can solve any situation and complete the puzzle. As an example, I will show you how 2 of these setup moves work. I will show first the number 1, which is a 3-cycle between this piece, and this piece. It's very simple. We rotate the right front edge, so this piece, which is in the 3-cycle, goes there. So this becomes a 3-cycle between this piece, and this piece. The red will go here, and the yellow will go here. So right, left, back, front, back, left, right, back, front, back. And do the setup move. The red has gone here, and the yellow here. And as a last example, I will show how the third setup moves works. And this is a setup move which cycle elements on the same face. In this case, the blue will go here, the white will go here. No, let's do this way so we can see. The white will go here, the blue will go up, and the yellow will go in this position. Setup move is very simple. We do back, then we do right back and right front. We perform the algorithm: right, left, back, front, back, left, right, back, front, back. We undo the setup move. So first is right front, then we did right, back, and finally back. As you see, the 3 pieces have been cycled. Applying all the setup move and these 3 cycles also in a symmetric way on the other side with the same principle, it's very easy to make the symmetric of this setup move from the one I gave you. You can solve any situation you have. Thanks for watching.